The goal of this problem is to solve this inequality after we get an accurate sketch of this rational function. So to start with, I put this thing into my graphing calculator, and I'm going to try to find these four things. So to start with, it was useful to take the original equation and factor it apart, so I say we start there. With the numerator, it must factor as an x plus and an x minus. It'd have to be positive 5 and negative 2. The product is negative 10, and the sum is positive 3. Now for the denominator, okay, again, you have to have a positive and a negative, and that's going to be positive 1 and negative 4 because the product is negative 4 and the sum is negative 3. Okay, with all of that, I now know where the vertical asymptotes are located. There must be one at negative 1, but also another at positive 4. And the reason for this is these two numbers make the denominator 0. So let's sketch that on the graph. At negative 1, we get a vertical asymptote, but also there's one at 1, 2, 3, and 4. Now the horizontal asymptote is going to be y is equal to 1. And that doesn't come from the factored form, that comes from this equation up here. I see there's a 1x squared and a 1x squared. The ratio of those two numbers is 1. So I will put in y equals 1 as a horizontal asymptote. Now for the x-intercepts, there are two. There's one at negative 5 and also one at 2. This comes from the fact that negative 5 and positive 2 make the numerator equal 0, and therefore the whole function equal to 0. So we can plot those. Let's see, there's one at negative 1, 2, 3, 4, negative 5, and also positive 2. And the y-intercept is going to be the ratio of the last two numbers, which is negative 10 over negative 4. That's positive 10 over 4. I mean, you can reduce that. That's the same thing as 5 halves. So that's going to be at 2.5. The last thing to address before we actually sketch this function is, does the rational function cross over the horizontal asymptote? And what I'm really asking is, does x squared plus 3x minus 10 divided by x squared minus 3x minus 4 ever equal 1? And I can see it does. Like in my picture, the graph, it comes down, and so it's going over the horizontal asymptote somewhere around here. This equation will find that value for me. So it's not a difficult equation to solve. I can take this entire denominator, multiply it to both sides, which simply multiplies it here to 1. My equation becomes x squared plus 3x minus 10 is equal to 1 times x squared minus 3x minus 4, which is simply this. I can subtract x squared from both sides, and my equation becomes 3x minus 10 is equal to negative 3x minus 4. Okay, I guess I'll add 3x to both sides. That gives me 6x minus 10 is equal to negative 4. Okay, I'm running out of room. I'll move that over here. If I now add 10 to both sides, I get 6x is equal to 6. Okay, obviously after dividing both sides by 6, I get that my answer is x is equal to 1. There's exactly one place where this function crosses over the horizontal asymptote, and that occurs at x is equal to 1, so it must be referring to this spot right here. So I'm going to mark that on my graph. And this means when I sketch my equation, over here, the graph is going to approach the asymptotes, go through this value, but it always stays below y is equal to 1. It'll never equal it. And the same thing is going to happen over here. It's always above the horizontal asymptote. We proved it can never equal 1 over here. So here's my graph. All right. In the middle portion, it's going to come down like this. go through those intercepts and approach both of the asymptotes. Over here, goes through that intercept and approaches the asymptote, never equals it. And the last piece is over here, okay, it approaches the asymptote and never equals it. And this is my graph. The last step is to now use this graph to solve this inequality. Where is my function equal to 1 and where is it greater than 1? So that means where's the graph above this line? Okay, so clearly we're not talking about this and we're not talking about this. We are referring to this piece and this piece. I'm going to highlight it. All right, so we're talking about this portion of the graph and this portion of the graph. The goal is for you to list down the x values. Okay, so the x values would have to be everything from -1 up to and including +1. So from -1, not including, up to and including 1, but also everything from here, this is 4, to +infinity. And this is the ultimate answer for this problem, and we got this by getting a decent sketch of the rational function.